Welcome to Math 330, Intermediate Algebra. This is our very first section. So it's section 1.1. It's linear equations in one variable. So this section is probably going to be review. When I say something is a review, I don't mean that I expect you to remember all of it perfectly. If I expected that, then I wouldn't be covering it. Everything we do here, you should be going, oh yeah, I remember doing that. I remember doing that. And this should come back to you as we are going along. If you find that you are really not understanding this, please contact me as soon as possible. You may have been put in the wrong math class, and it's better for us to figure that out early than it is for you to try to struggle through the class without having the proper background to get it done. Now, as I work through these, I'm going to be showing you a couple of tricks on these calculators. They're very similar. They're both very good. If you were in the classroom with me, we have classroom sets of this one. This one's my personal one. I find them both very friendly. They're very, very similar. This one has a few more capabilities than this one does, but it's up to you. Okay, so let's start off by talking about some of these properties. I'm always going to give you formal definitions before we start working a new topic. Now, it takes practice to be able to read these. I will always explain them, okay? The first thing we have is the addition property, and it says also subtraction. Most of the time, if we have an addition property, we also have a subtraction property. And that's because subtractions can always be rewritten with a negative number and making it addition. Okay? We also have a multiplication property, which is also division. And this pairing happens a whole lot too, because if we are dividing, we can change it into multiplying by a fraction. So we can always write a subtraction problem as an addition and a division problem as a multiplication. That's why they tend to go together. What this says is if we know two things are equal, whatever they are, then we are allowed to add or subtract the same thing to both sides, and it's still true. Okay? Now with multiplication and division, if we have two things that are equal, then we are allowed to multiply both sides by the same value. Those are our C's, okay? So basically, when we have an equation, which means we have the equal sign, then we can add, subtract, multiply, and divide both sides by the same value, and we still have something that is true. Okay, so let's look to solving our first equation. Now, I'm going to be skipping some steps. I will always say it, and I usually mark what I am doing, but I don't always fully write down the next step. Okay, so what I mean by this, right here we have 5x plus 2 is equal to 3x minus 6. If we're supposed to solve this, we want to get our x values on the same side. It does not matter whether we move the 5x to the right or if we move the 3x to the left. It works either way. Most people have a preference to either make the coefficient of x positive every time or to get the x on the left every time. It's your personal choice. It makes no difference whatsoever. You should end up with the same answer no matter what. Okay. For me, though, I want to move this 3x over to the left. So I'll usually draw an arrow indicating what it is I'm trying to do. Okay? This helps a lot because if you make a mistake, you can easily see what it is that you tried to do, so you can easily check that step. Now, what technically we're doing here is, to move this over to here, I'm technically subtracting 3x from both sides. This is the step I do not generally write in this course. I say we subtract 3x from both sides, but I don't usually write it. 5x minus 3x is combining like terms, which would give me 2x, and then plus 2. This would cancel out, so it's equal to negative 6. Now I'm going to do the same thing, getting this thing by itself, so I need to move the 2 over to here. Okay, one side note about my personal handwriting. My z's and my 2's tend to look alike. If you see this, it's going to be a 2. If you see this, it is a z. Okay, my z's always have lines through it, so if it doesn't have a line through it, it's a 2. All right, so come back to here. If I'm going to move the 2 over to here, I am subtracting 2 from both sides. So I said it. If I subtract 2 from here, this cancels, and I have 2x equal to -6 minus 2 would be -8. Okay, now 2x, this is 2 times x, so I am going to divide both sides by a 2. And then we get, that's going to be 1x, which is just x, equal to -8 divided by 2 would be -4. Okay, now I'm always going to suggest that you take the time and check your answers. I don't have to see it, of course, because you can do the checks in your calculators. So what I'm going to show you right here is how to use the memory on these calculators. They are the same on this, okay? My answer was -4, so I'm going to type in -4 onto both of these. And then if you look right here on both of them, STO with an arrow, that means store. So I'm going to store it, and then what happens is it puts the arrow in, and that's on both of them. And then hit your variable button right here, which is X. So if I hit that, now on both of these it says that, and I hit enter, and it tells me that it's done it. Now every time I hit the variable and just hit enter, it has -4 in it. So now what I'm going to do is the same on both calculators. I'm going to enter this side. So I'm only going to do it on one here so you can see it. 5x, so I hit that button right there, 5x plus 2, and it tells me it's -18. Now I do the other side, 3x minus 6, I should get -18 again, and I do, so it's correct. Now, -4 is not a hard number to plug in your head. It's not hard to do the arithmetic. But this is a trick you can use when you have ugly fractions as answers and things like that. The store and recall works exactly the same on both calculators.